and I'll be your speaker for the day. And today's topic is about, can technology be used for wastewater recycling? So gear up, we're starting with the main presentation right now. I assume all of you can see a panel on the right side of your screen, which is the GoToWebinar panel. You can use this panel, you can use the questions dialog inside it to submit any questions that you have. We will be answering all questions towards the end of the session. This is to ensure that my presentation is seamless and everyone can hear everything that I have to say in one shot. And then at the end, I will be taking up all the questions that we have. Also, this webinar is being recorded. So the recording of this webinar will be made public after the session. So if you do have to drop off in between, or you're planning on taking any notes, you don't need to take any notes. You will have access to the recording as being part of it. So let me start by introducing the WRC Blockchain Hackathon. This is a global initiative by 2030 Water Resources Group, which is hosted by the World Bank Group, MWRRA, and also the Bombay Chamber of Commerce and Industry. This hackathon is going on to basically solve the water problems, and we want to see if you can code for a cause and really contribute by means of software into helping solve some of the water challenges that we globally have. So I know some of you attending this webinar are already registered for the hackathon. Maybe some are not registered, but if you're interested in making a contribution, the link to register is wrc-hackathon.devpost.com, and it's the same platform that we use for capturing all submissions. So let me get to the main topic. And we want to see if we can actually use technology to help solve water problems. And by technology over here today, I do not mean hardware technology. I'm actually referring to software technology. So if you look at an industrial flow of water, a standard industry in most cases, it could be pulp and paper, it could be automobile manufacturing, it could be water heavy industry or non-water heavy. Most industries will require some amount of fresh water that they take from the environment. There is the water goes to an industrial plant / industrial park. This plant uses the water and produces wastewater, which is where what is measured at point A. Then the wastewater goes to a wastewater treatment plant. The wastewater treatment plant treats the wastewater, and some of the treated wastewater is further polished and reused back by the plant itself. But some amount of the wastewater cannot actually be reused, so that wastewater gets discharged to the environment. Now, what's important is the water discharged to the environment needs to meet regulated standards, and in most cases, it does meet regulated standards. But what we are trying to say is that industrial plants also have to recycle some of the wastewater, which means they reuse it, they process it, and they reuse it back in their own system. So what we have observed in practicality is many of these industrial plants actually skip recycling and reusing the wastewater. The classic reasons for doing this include that fresh water is easily available. So they can draw fresh water from ground, or bore wells, as we call it, and reuse it in the manufacturing plant. So they're getting the water almost free, fresh water almost free. Recycling is costly, but fresh water is free. And even if you're drawing fresh water from municipality supplies, it's still not very expensive. So they use fresh water instead of actually recycling water. So it's cheaper to not recycle. Then the additional problems include it's actually hard for authorities to track the amount of fresh water these organizations are drawing, and it's also difficult to track if they are recycling any of the wastewater. So in general, there is a severe lack of motivation in doing recycling. But as these plants operate, we are seeing that there is a tremendous strain of water resources and water supplies that we see in the general environment. And the 2030 Water Resources Group is actually aimed at improving some of the situations of water supply, because what's known and statistically known is by the year 2030, we will actually have lesser water than what the world will demand. And that's a problem. And it's something that we need to do today to basically solve the problem. And a lot of the problem involves in proper recycling and reuse of some of this wastewater. So the clear problems being that freshwater intake is very hard to track. The discharge of water is also very hard to track. So in many cases, the discharge happens in dedicated channels that go to the local bodies, and these local bodies further purify the water or recycle it, and then resend it back to the environment. But in several corporates, discharging of wastewater happens on open grounds, which seeps into the ground itself. It also happens by means of illegal tunnels that they have dug. So they have dug wells and they have dug deep tunnels, and they discharge really harmful water, which is non-purified, into the ground and into the environment. A lot of this is hard to track because there are too many companies, too many plants, and tracking this across all of them is almost impossible, especially in a country of the size of India. It's very, very difficult to track this. So how much water they draw from the ground or how much fresh water they take cannot be accurately measured. What they discharge, how do they discharge, it also cannot be accurately measured. There are severe challenges in being able to measure that. But there are a few things that we can know for sure. Is we know what is the production output of the industrial plant. So we know how much goods they are manufacturing, and a lot of that information can be derived from financial returns that these companies file with the income tax department. So we know the revenue. The revenue tells us how much manufacturing they're doing. And based on the manufacturing, we have an average estimate known per sector saying that if you manufactured so many tons of steel, you would produce so many gallons of wastewater. So the figure A, which is the measure of volume of wastewater, is somewhat known per company based on the manufacturing capacity of that company. Then what we also do is the regulator basically now sets a target saying that a certain percentage of the wastewater that you produce, and how much they produce is at a high level known. The regulator goes in and sets a target. A certain percentage of the wastewater that you produce needs to be reused back in the same system. So how this works is because we know A, we can set the target for B, and B is again a volume measure. So if we know arbitrarily that A is a particular figure like X, and if we mandate that 30% of A is something that they need to recycle and reuse back in their industry, and the regulator can set this based on types of industry, then we know that 0.3 of X is something that needs to be reused by the plant. Now, let's say that the regulator, that the organization basically meets this recycling target and does recycling. So we can reasonably assume that if the organization recycles its wastewater, then waste released by the organization to the environment is automatically reduced. So the amount of output waste they put into the environment and the amount of fresh water they draw from the environment is automatically reduced if the organization recycles and reuses some of its own wastewater. Now, this is an assumption we are making, but it is reasonably accurate. So the way we do this is we basically set up a plant wherein we have full traceability. So within the borderline, we know exactly what is happening because this is happening within the premise of the corporate. And we have fresh water that we take in, which cannot be measured. There is discharge happening to the environment, which cannot be measured. But what's happening within the plant, a regulator can measure by installing IoT meters. So let's say we install meters at 2 points, which is one IoT meter is installed at point a second IoT meter is installed at point B. The meter at point A measures volume of water per hour, and it reports the data point every hour. It only measures volume. We don't need quality measurement at point A because we know that the water does not meet any quality standards because it is actual wastewater produced by that industry. Then we have IoT meter at point B, which measures volume and quality of water per hour. So the meter B is doing both measurements of volume as well as quality. And the reason we measure quality is because the wastewater treatment plant basically needs to do certain treatment of the water so that the water meets a minimum quality standard before the water is gone back into the recycling process. So if we look at the measurement by B, is basically the water quality standard that it needs to meet is the water the water input into the wastewater recycling plant needs to have a pH value of 6.5 to 8.5. It needs to have suspended solids that are less than 50 milligrams per liter. It needs to have hardness that is less than 45 milligrams per liter. It needs to have oil and grease, which is less than 5 milligrams per liter. And the BOD value should be less than 5 milligrams per liter. So if the water meets some of these standards, we treat it as an industrial zero. An industrial zero means the water is actually clean to use, probably not as clean for drinking, but it's as clean to be used in certain cooling towers to use inside the air conditioning systems that we use in the buildings. The meter A measures only volume of wastewater produced, as we saw. Now, the regulator will set a target for percentage reuse of wastewater. So how do we treat percentage reuse? So percentage reuse equals volume measured by meter B divided by volume measured by meter A into 100. So 100 gets us to the percentage. Now, the volume of B will obviously be less than volume of A, but we are not measuring only volume of B. We are measuring volume of B, only the clean part of it, which means the volume measured by B that is within the quality standards that are set is counted. If the meter at point B measures water, but if the water doesn't meet the quality standards that are set, it won't count as percentage reuse. So only the clean part of the water, which is within the set parameters, will actually count as recycled and reused water. So percentage reuse equals volume measured by meter B clean, the clean part of it, divided by volume of A into 100 to make it a percentage. And the regulator will set a target per industry and per company on how much percentage of their water they should reuse. Let's not forget that volume of A is somewhat known based on the manufacturing output that the industry or the company specifically has. Now let's look at how enforcement of percentage reuse works. So as we discussed a little earlier, most corporates are actually not motivated to recycle some of their wastewater. And that's because fresh water is readily available. Fresh water comes at almost zero cost. The water from municipal supplies is also at a very low cost. So why would they spend money in actually recycling some of the water? But recycling is a need if we want fresh water to be available going forward. So the regulator, let's say, sets a target of 30%, and a company A, some company meets this target. Now, let's take a company B, which doesn't meet the target. So this target of 30% is a percentage reuse target, which is computed by the same formula I mentioned earlier. So if you're looking at company B, the company B only recycled 20% of its water. So recycled and reused only 20%, but the regulator set a target of 30%. So they are short of the target by 10%. But let's say we take a company C, which did an overachievement of its target. So they recycled 60% of the wastewater they produced, right? And but the regulator had set a target for 30%. But they overperform, which means they are being better to the environment than what the regulator defined average or the target is. So what should happen in this case? Company B has to pay some penalty, and company C has to get some benefit in overachieving the target. So what we are saying is per volume measure of wastewater that is reused, we will give these companies certain amount of WRCs, and WRC is basically wastewater reuse certificates. So these could be digital tokens which are issued to the company based on volume of water reused. Now, the percentage of water reused is also tracked independently. Percentage of water reused has nothing to do with the volume that's reused. So per volume of wastewater that is reused, which is the volume measured by B, and the clean part of it, which is B clean, not the non-clean part of it, only the B clean part of it, will per volumetric measure, each company will get certain amount of wastewater reuse certificates, which is basically guaranteeing, it's basically proof that you have reused some of your wastewater. How much percentage is different. So company A achieved certain number of wastewater reuse certificates. It met its target of 30%. It has no penalty to pay. It has nothing to gain. It exactly operated as per the target that was issued. Company B underperformed. It achieved, let's say, 1,000. It got 1,000 wastewater reuse certificates, but it only recycled 20% of the wastewater. So it has to buy some of these additional certificates, is what we're saying. Company C, on the other hand, let's say, got 4,000 wastewater reuse certificates because they actually overachieved their target. So they have excess number of certificates than the target that they have. Now, what we are saying here is to enforce the penalty, there will be a transfer. So company B will have to buy wastewater reuse certificates to meet their 10% difference from company C. So company C will sell 10% of its certificates to company B, right? So company C has basically 30% extra certificates because they did recycling of 60% instead of 30%. So they overshot the target by 30%. So they have 30% extra certificates, but company B has 10% less certificates. So company B needs to buy those 10% worth certificates from company C. So company C is automatically getting a benefit because it can now sell the certificates. Company B is paying a penalty because it has to buy those certificates, right? And company A gets neither. So company B cannot buy certificates from company A because company A did not overachieve it, so it does not have excess certificates to sell. And each certificate is a measure of goodness done to the environment. And company C has been very good to the environment. So whatever company C outperformed in was lost because company B underperformed. So company B caused more damage to the environment while company C caused less damage to the environment. And they caused it in probably similar proportions. So 10% of the additional certificates that company C has will get sold to B. The price of sale will be determined by the regulator, and the price will change every year. And the price is actually a function of how much it costs to recycle wastewater. It's not how much it costs to draw fresh water. So now if these companies are going to pay a penalty because they did not recycle a certain percentage of the wastewater, then they are automatically motivated. So they're now motivated to recycle and reuse some of the wastewater, which without this concept, they're not motivated to do. So the proposed solution is feasible in motivating the corporates. It's also feasible in being able to track because the measure of volume A, which is the wastewater, is known. The volume B can be measured by installing IoT meters. Both A and B can be measured by installing IoT meters. And these meters are within the company factory. It's not related to freshwater intake. It's not related to final discharge into environment. So these are traceable components. So we can measure them. We can mandate a percentage reuse. And we know that if the company reuses a certain percentage of its water, then automatically that company has drawn lesser fresh water, and automatically it has discharged lesser dirty water. So it tracks reuse, thereby tracks reduced waste, and the implementation itself can be audited by visiting the company and the regulator coming in and installing some of these IoT meters. But there are still problems. Some of the problems include data tampering, which means the data that's produced from these IoT meters needs to be stored somewhere. And the place at which the data is stored, the data can be manipulated. It could be tampered with. Somebody could report fake data points. The IoT meter itself could be tampered, which means while they're discharging, while they're not reusing as much percentage of the wastewater, or the wastewater that they're reusing does not meet the desired quality standards, but the meter is still reporting that the water meets the desired quality standards, is because the meter is now actually tampered with. So the meter uses certain sensors that look at the water flow through a pipe, and the sensor itself could be manipulated or played around with to start reporting incorrect data. Then we also have problems such as there could be a power failure. Now, a power can fail and the IoT meter would stop working, but the water may still flow through the pipe. So this works both ways, wherein a company could intentionally shut off the power of the meter when they're discharging wastewater that's not in the acceptable standards. And on the other side, a company could be genuinely putting water into recycling, which meets the environmental standards, but it has a legitimate power failure in the premise, or the meter has failed, and the meter is no longer reporting data. So while they have been environmentally friendly, they have recycled some of their water, they're not getting the wastewater reuse certificates because the meter itself is off, right? So both sides, there's a problem, and this needs to be addressed. Now, a blockchain itself can address some of these problems. What a blockchain can do is basically ensure that data once reported onto the blockchain cannot be changed. Now, this is essential because if the same data from IoT meters was reported into a software database, we know that a database administrator could actually change the data that is reported. But if the same data that is reported by IoT meters is going into a blockchain, then we know that the data cannot be tampered with. Then a blockchain can actually be made public, which means it can be in the hands of the public and run on public servers. So there is public traceability of compliance, right? So the public can actually trace if a water reuse is indeed happening and if some of the corporates are compliant. Then the blockchain system in itself could actually set up smart contracts. So if the regulator is setting a target saying that you need to recycle and reuse 30% of your wastewater, then that target could actually be set up as a smart contract. So there is no dispute on whether the target was 30% or it was 40% or it was 35% or 20% or 25%. There should be no dispute. So the regulator sets up a smart contract on a public blockchain. So the smart contract is registered on a blockchain. And the smart contract could operate on a private blockchain, which could be run off Hyperledger. It could also run on the Ethereum network, wherein you set up a smart contract on Ethereum, or any of the variations of blockchains that are out there. But what's essential is you basically set up a smart contract between the regulator and each organization, right? And everyone can verify that this contract is in place. What is the exact percentage reuse target set by the regulator? Regulator cannot change the target. Neither can the company change the target because now the smart contract is in place. It also ensures that, let's say for steel manufacturing, regulator has set a target of 30% to company A, then one can also ensure that another company B, which also does steel manufacturing, is also got the same target of 30%. So it should not happen that one company is given a target of 60% and another is given a target of 30%. In the same industry, the target needs to be the same. But different industries could have different targets. So it could be 20% for automobile manufacturing, it could be 30% for steel manufacturing. But all automobile companies should have the same target. All steel manufacturing companies should have the same target, which is basically being fair, and smart contracts can guarantee that fairness and clarity of what the understanding is between the parties. Then there's also traceability of penalty enforcement. So while we saw in the previous example, company B has to acquire the certificates from company C, which is the wastewater reuse certificates. Now, to acquire the certificates, they are going to do some monetary transaction to company C. So company B is going to pay some money to company C. This transaction itself can be put into the blockchain system. So if the transaction has happened, then we know that company B violated the set target, it underachieved it, it could not meet it for any reason, but it did indeed pay a penalty. And the payment of penalty transaction needs to be on a blockchain so that one can enforce that the penalty is enforced, right? So the tampering at the source itself is still a problem though. So let's say the meter is tampered, the blockchain can't do anything. So although we would issue wastewater reuse certificates from data that's reported in a blockchain, and it's essential to issue those based on data that's only within the blockchain can also protect against not allowing reporting of historic data. So let's say if your meter was off, it was off, sorry, you can't report any data, right? And if you missed the slot to report data, it's missed. You can't now add it in the future in the blockchain. It also guarantees that the data cannot be changed once it's inside the blockchain. But what it cannot ensure is the quality of the data itself. How do we know if the meter itself is tampered with, right? So can we use certain machine learning to track if data is tampered at source? So let's say we have an auditor who will go and audit the factory floor maybe once a month. So the auditor goes to the factory, calibrates the meter. Most of these meters require frequent recalibration. So let's say we do that recalibration once a month. Now, when that person is inside the factory, has recalibrated the meter, has audited the system and checked that it is measuring the right water and it's measuring all of the wastewater and all of the recycled water. At that very moment, we know that the quality of data is accurate. We have to assume that when the regulator is inside the factory floor, the data that we get is very accurate. But after the regulator has come back to his office, the company could tamper the meter itself, or they could rewire the pipes. So let's say they are discharging its waste into the environment, but they have rewired the pipes so that fresh water passes through some of these pipes. So a meter start detecting that yes, water is indeed flowing through the pipe, and it also detects that the water is extremely good quality because it came from the ground. And if they draw the water from the ground, we don't know, there is no measure. If they draw the water from municipality supplies, the municipality meter will at least measure some water. But if they draw it from the ground and pass it through the pipes on which the meter is connected, we will never know. And because it's fresh water, it will probably meet the quality standards. So can we use some models such as anomaly detection in machine learning to track for sudden changes in water quality patterns? And a sudden change should alert the authority saying that, yes, indeed, there is some tampering. Now, can these algorithms be used? What would be these algorithms? Now, some of this is really in question, and a lot of innovation needs to happen in this space. Then how do you even track power failures or spotty internets? So let's say we are saying that data reported in a blockchain cannot be changed. Yes, but if the meter is off and the organization is still recycling the water, then how do we measure it? Whether they're recycling or not, right? And what is the way to do this? So this still requires innovation, whether we put battery in the meters, but even if we put battery in the meters, it's also possible that the internet is spotty, which means unreliable. So the meter is not able to communicate with the servers at all points in time. Maybe it is able to communicate for a few hours in a day, but not every single hour, so it can't report a data point every hour. And these are practical challenges because many of these factories are not within city limits. They're outside the cities where internet or cellular connectivity is really poor. So how do we solve for these issues of data consistency and data accuracy is something that's still a question on how whether technology can really help solve some of the water reuse problems and add traceability to the whole system. So in general, this is exactly why we are running the WRC Blockchain Hackathon. We want innovation that tells us if we can use blockchain. If we can use blockchain, then how do we set up the smart contracts? Then if the smart contracts are set up, can we measure the data inside the blockchain to issue wastewater reuse certificates? Can we ensure tradability of these wastewater reuse certificates between organizations that overperform and organizations that underperform? Then how do we also use some technologies like machine learning and AI to track if a meter is tampered with, or if the companies have rewired some of the piping to pass fresh water through the meter so that we are getting inaccurate measurements? Can we use some of these algorithms to track it? How do we track power failure? How do we give credits against power failure? How do we handle intermittent internet connectivity challenges? Is something we want to is something we strive for as innovation as part of this hackathon. So for all those of you who have registered for the hackathon, I do hope that this webinar has offered some more clarity on some of the challenges we face and has given you certain ideas that you can come and submit as part of the hackathon on how you propose to solve some of these challenges. For those of you have not registered for the hackathon but think have an idea, please do register. So we give 15% score to a functional implementation. So while we know blockchain is a new technology, and a lot of people have actually never used a blockchain, so there may be challenges in setting up a blockchain. We recognize this. So we will not hold you accountable if you're not able to set up a blockchain. But if you are able to set up a blockchain and show us a demo on an actual blockchain, then yes, you do get a percentage score, which is the 15% for a working prototype. But let's say you're not able to do that. 85% still goes into the uniqueness and the innovation that you offer as part of a solution you propose. So you can still make a presentation on what solution you're proposing. Give us a demo of your own, give us a video recording of you presenting your own presentation. And we will have the entire panel of jury look at it. And what we really strive for is innovative ways to help solve all of the problems that come in practical implementation. So while we know the proposed structure works in theory, it doesn't actually practically work when we install it on the field because internet connectivity is poor, meters fail, the meters are installed inside the corporate's premises, which are outside the regulator purview. So the meter themselves can be tampered with. So there is data fraud happening. Although we have put data on a blockchain, there's still data fraud happening because the data going into the blockchain is incorrect. Then how do we even add security protocols to make sure that only authorized meters report data into the blockchain and unauthorized meters don't report data in the blockchain? How do we do this? So these are several challenges. And we are using this hackathon to drive certain really innovative solutions. So even if you're not a coder or you're a coder but don't know how to code a blockchain, but you have an idea that can really help solve some of these problems, we want to hear it. And for all you know, your idea may actually be used by the organizers to go out and make a real life implementation. And you may also get the opportunity of working with the organizers to implement this idea in real life. So we do strive for your solutions and hope you can make some significant contributions. So I think that's all I have for now. So I see questions piling up. So let's move to the much awaited Q&A. I'm reading the first question that we have, and we have a question from Ishita Goyal. And her question is, I want to know whether you will be making available any training data set for fraud detection. So Ishita, the answer to that question is yes. There has been certain delays from our side in releasing training data, but you should have it by the coming Wednesday. And that data will give you a lot of meters and sample data from a lot of meters. And you can use that data to detect any frauds that are happening in the data reporting. So let me move on to the next question. I hope Ishita that answers your question. If there's any further question, please do write in. We have a question here by Avinash, and he's asked it pretty much in the beginning of the webinar. And the question is, why can't freshwater intake be measured? So that's a very good question, Avinash. So the basic problem with measuring freshwater intake is it could be taken from multiple sources. So you could get water trucks that come and deliver water to you. So the water coming from the trucks, it's very hard to measure. You could draw water from the ground, which is wells. So you dig a well and you draw water from the well. It's very hard to measure how much water a corporate draws from these natural sources or even unnatural sources by ordering it, getting the water shipped to you. If you do take the water from municipal supplies, it will be possible for the municipalities to measure by using a meter on how much water is going into your plant. But you can't actually do that when water is available around you. You could draw it from a lake, you could draw it from the ground, you could order it in, load it into trucks, and get it and give it to your factory. And let's say you're supplying water into the same freshwater pipe. Let's say you have just one single freshwater pipe taking the water in. And you could, while you're supplying the fresh water into your plant, you could turn off electricity to the IoT meter. So it's almost impossible to capture the freshwater intake that's happening. And I see you have a second question, Avinash. So the second question is, what happens with rest 20% certificates? So I assume what you mean here is basically the company C that I was talking about, which missed its target, recycling target. So company C gained, overshot the target by 30%, while company B had a target of 20%. So I assume that's the question here. So company B recycled 20% of its water, but its target was 30%, so it was short by 10%. Company C recycled 60% of its water, so it overshot the target by 30%. Now 10% of the certificates need to be bought from company C, bought by company B from company C. So company C will sell 10% of its certificates to company B because company B underperformed. So I assume the question is, what happens to the remaining 20% certificates of company C? So the remaining 20% certificates of company C, the company C would basically sell it to other companies who don't meet their target. So we're not looking at an ecosystem where there are only 3 companies, A, B, and C. We're looking at an ecosystem where there are thousands of corporations across the country, and some are missing the target and some are overachieving the target. So the ones who overachieve can sell the certificates to the ones that underachieve. That's the purpose. It's not necessarily that one organization sells only to another organization. So company C could sell its certificates to effectively 3 different companies, 10% each. So different companies would buy certificates from company C until they have sold out all of their certificates. So I have one more question, which is I'm going to actually I have Mahesh Patankar from World Bank from 2030 WRG Group, and I want to see if he can answer this question for us. So the question is the regulator going to pay all organizations? Is the regulator going to pay all organizations if all of them overachieve their target? So Mahesh, would you be able to answer this?
Yes, thank you, Sanket. Yeah, so the question is about if everyone overachieves, if they would monetize. We need to understand the water use and water recycling from the perspective of it making a business case. So, reduced water consumption would mean reduced factor cost of production in any kind of industry, be it steel, fertilizer, and so on. So, there are two or three things that are happening here. First and foremost is that by reducing the overall water consumption and recycling it, the companies are benefiting on their own in any case. This is a market and an additional market trigger is being provided through the tradable permits, which we call as wastewater reuse certificates. So that's an additional, that's like a booster. Okay. So the first and foremost thing is the businesses would be able to save their input costs, and more importantly, some of them also have their own sustainability targets. They can also do their own internal benchmarking. Imagine a multinational company working from Brazil, South Africa, Vietnam, India, Australia. So they can actually benchmark their own processes and set their own internal targets. So all of this exercise that we are doing is not only to meet the regulatory compliance, but there is a substantial business angle to it. I hope that answers your question. Over to you, Sanket.
Yeah, thank you, Mahesh. I actually have one more question for you, Mahesh, if you can answer that as well. So this question is asked by Wasim, and the question is, on what basis is the target set per industry, and how is it determined that they have met the target? And is the target basically a percentage of water use or the quality standard, or is it both? So do they have to meet both percentage and quality standards? Mahesh, you want to answer the domain side of it, and I'll answer the tech side of it?
Yeah, sure. So let me start with the second question, or second sub question, which was about would there be a target on the quality and the quantity? I think yes, the target will be on both quantity, which would be captured as a percent of the wastewater that gets otherwise discharged into the environment. And the quality is again important. We cannot really have substandard quality water going back within the industry, so that it has to be more than the regulatory compliance otherwise. So, for example, different countries have their own environmental standards, which means a particular industry cannot discharge water which is more than a particular pH level. So obviously, water that we're trying to recycle has to surpass that regulatory compliance level. So it's again, to reiterate, it's a combination of quantity and the quality. Now, coming to the quantity part of it, your question is very interesting. How do we really set the targets? The target is set on the basis of best available technology that is being used in a particular industry. Imagine a textile industry. A textile industry of 1950 vintage and the textile industry of 2018 vintage would have different technologies that are being used. Say, for example, a jet dyeing machine. So the jet dyeing as a technology is moved beyond its original form way back in 1950s, and 2018 technology is a lot different, which also means it's a lot efficient. Okay, there is a substantial learning curve that has gone into the technology progression itself. So the targets that are set by the regulator is a combination of what is the best available technology in the market, what they ought to be using, what are they actually using, and all of that is determined by some level of water audit that would be conducted pertaining to these large water guzzling industries. So, as a part of the regulatory compliance and the regulatory mechanism, there would be obviously some level of normalized way of stating that all the textile industries are capable of recycling at least 15% wastewater, which then would become their own benchmark. So, minimum performance standard, let's define that as a wastewater recycled, would be at least 15%. Okay, and it could be a different number for a pulp and paper industry. It could be another different number for a power sector, which is a thermal power generation plant. So it would sort of differ from industry to industry, the type of technology that is being used, and the water stress and the environmental stress that they are putting onto the ecosystem itself. And here, what I mean by ecosystem is basically ecology. So I hope that answers as well. Please feel free to ask further questions on these lines if you have any. Thank you. Back to you, Sanket.
Yeah, thank you, Mahesh. So, Wasim, yeah, so from the technology standpoint, to answer your question, basically, we will be analyzing all the data that's in the blockchain. So we are assuming the IoT meter data, point A and point B, all go on in the blockchain, and then we track percentage reuse. We don't track freshwater intake, or neither do we track the discharge. We track the reuse, but only the water that meets the quality standard is counted in the reuse. Water that's reused but doesn't meet the quality standard is not counted in the reuse. So I hope that answers it, Wasim. If there's any further question, please do send it across. Moving on to the next question by Eklin Kaur. And the question is on the IoT meters will display the target achieved by a particular organization in the ledger. So that record itself goes to the organization that is issuing the panelists of meeting the borderline recycling the wastewater. So how does the organization check for IoT meter tampering? So Eklin, to summarize your question, I believe it's related to tampering of the meter itself. So what happens if the data that's sent into the blockchain is actually incorrect? So I see there's a second question from you as well, which says blockchain allows immutability, but how do we ensure that the data is not tampered before it is sent into the blockchain? So that's a very interesting question, Eklin. And the truth is, we don't actually have an answer. And that's why we're doing the hackathon. So we want to strive innovation to see what are solutions that are possible to prevent some of this tampering. But high-level thoughts on this topic include, let's say, the use of machine learning and AI to detect changes in reporting patterns. So it's reasonable to assume that an industry would produce a certain amount of wastewater, and the quality of this wastewater would be within a particular range that's very, very specific to the industry. So in a sense, we can actually say that each industry will have its own signature of wastewater, and it will be unique to that particular company. It will be unique per company. And that signature can vary based on the atmospheric conditions, humidity, weather, time of the year. So it would vary, but it would still have a particular signature given certain environments amid. Now, the meters have to be recalibrated. So it's reasonable to assume that the regulator is going to send some person to the factory, and that that person who is appointed is going to calibrate the meter. And this data point of when the meter is calibrated needs to be recorded in the blockchain. So it is reasonable to assume that in the hour when the meter is being calibrated, a few hours after that, the data that we get is 100% accurate. And that's the reference. Now, if the data starts changing, so next day after recalibration, if we see a sudden change in the data, sudden change in volume, sudden change in quality, then we might have to raise an alert saying that there seems to be some tampering after the recalibration. So that's the assumption. But can we actually find this out by using some algorithms of machine learning that do anomaly detection? Can we check for deviation from a normal pattern, simple statistical models to track deviation, and flag it up so that a regulator can actually go do a surprise visit into the factory and re-inspect the meter when we have raised an alert? So that is some of the innovation we really want. We don't have a ready solution for it. So we want to know what are the various algorithms you can use to ensure that the data comes in the particular quality, in the right quality. So moving on to the next question. I hope that answers your question, Eklin. And if not, please feel free to ask more questions again. So Eklin is basically, Nicole is asking a question, which is basically, is there a system in place to keep companies from making fraud companies that are set to not meet their target intentionally, to only buy certificates from the mother company who over met the target? So what she's saying is, would companies, the actual company, set up fraudulent companies to buy the certificates from the mother company when the target is to basically buy the certificates when the target is not met. So I think, Nicole, this is a possibility, but there are probably ways to prevent this. So what we need to ensure is which organizations are registered on the blockchain. So a regulator must register an organization on the blockchain, right? Now, but it's possible that a company creates a fraudulent company, correct? Which is fine. But now, for this fraudulent company to get the wastewater reuse certificates, they actually have to do some reuse of water. So if they are doing reuse of water, they first are producing wastewater to start with. This is a fraud company that I'm talking about, right? So they need to have some plant or some industrial plant that is first doing some type of industrial manufacturing that produces wastewater, which is then recycled and reused. Now the regulator is going to register this company into the blockchain. Why? Because they are a legitimate company registered with the authorities. So it's a legally formed company as far as the government is concerned. But they also need to have some plant, some setup, some place where they consume water, where the regulator can send a person to install the meters. So the setup has to be there. And then that setup needs to start reporting data onto a blockchain, both data points, which is meter A and meter B. And then this setup needs to now overachieve their target that is set to them by the regulator. And after they have overachieved the target, if their primary company underachieves the target, they may be able to purchase certificates from the overachieved company. So what we're saying is even the trading actually goes through a regulated mechanism. So there'll be a third-party body that handles the transfer of the WRCs between company A and company B. So it's not necessary that the fraud company can sell to the primary company, but the fraud company can still sell its wastewater reuse certificates to some company, doesn't matter who, they get the money back. But in order to do so, it's not just the quantity of water, it's the percentage of reuse that meets a quality standard. So how do we actually, if the company can, if the fraud company can meet the quality standards and meet the target for percentage of reuse, and they indeed do some level of manufacturing, then why cannot the same company that formed the fraud company do exactly the same thing in the primary company? So why would they be motivated in underperforming in the primary company and then overperforming in a fraud company and effectively nullifying the gains when the fraud company is going to have the system to actually recycle the water? They should actually use the same system in the primary company to recycle the primary water and get those wastewater reuse certificates. And then instead of trading those certificates between themselves, they would rather sell it in the open market and actually make money, which gives them a benefit against the cost that they incurred in recycling the water. So it's possible that if they overperform the recycling target and significantly overperform, it's possible that they actually make money from recycling, which means the cost of recycling is lesser than the gains they get by selling the excess certificates. And that is what each company should desire. And they should look at this system as a means of making additional money while at the same time being environmentally friendly. Right? So I hope, Nicole, that answers the question. I actually hope it answers the same doubt that a lot of others may have. Right? So, okay. So also looking at other aspects, so we have more questions here. I'm going to take one or two more, and then we're reaching the end. I'm just going to take one or two more. So there's a question by Avinash, and he's saying the fresh water is cheaper than the recycled wastewater. So why would they actually recycle? You know? So the obvious answer to that is we're going to charge the companies, the regulator will charge the companies a penalty if they don't actually recycle a certain percentage of their wastewater. So while they can continue taking fresh water, which may come to them free of cost, the end of the year, the penalty that they have to pay will probably be more expensive than the cost they would have incurred in recycling their water and reusing it. So they would be motivated to actually recycle their water. And we are also looking at basically, so there's also a question of, I think, net overachieving the target is being a pertinent question. Multiple people are asking, the same question on net overachieving, which means if every company overachieves the target. So if every company overachieves the target, that's very good. But what's essential is that the regulator is basically going to do a periodic audit, right? So the regulator knows what's practically possible and not possible. So there is actually no magic in which a company can significantly overperform to the extent that every company significantly overperforms, because the technological investments required in these recycling plants cost a lot. So they cost several crores of Indian rupees. And for every company to put that in one fine year and overachieve, and to the extent that everyone overachieves the target is kind of impossible. But it's possible that majority overachieve, minority underachieve, in which case the price at which the WRC is traded is also set by the regulator. So if there is excess number of people who overachieve and less number of people who underachieve, then the cost of one WRC would be lesser, right? Because you have a higher number of overachievers and a lesser number of underachievers. But let's say there's a more number of underachievers and there's a higher number of overachievers, the cost of the one WRC would be higher, which means that the few people who overachieved now make a lot more money to sell their certificates to the ones who underachieved, right? So that is how it would work. So that balances the system in a way. Now, so Wasim's question in addition after that is, what is the duration after which the readings are checked by the auditor? So a lot of this is industry dependent. So in some industries, it may be every 15 days, some may be every month, some may be every 3 months, some may also include surprise audits. So that really depends from industry to industry and the type of meter being used and the frequency at which they have to be recalibrated. So Eklin has another question. What if company doesn't trade the extra certificates for money? Is there any chance if the company underperforms in the next data analysis, it is expected from paying the penalties, exempted from paying the penalties, or it can somehow reuse the previously owned certificates? So yes, that's possible, Eklin, wherein, if somebody does overachieve their targets and is not able to sell the certificates, there may be an offset given in the next year, which means in the next year, if they underachieve, they can use carry forward certificates from the previous year in the next year. But this is not determined exactly at this point in time. So it's the regulator decision on how to allow it. In some cases, if you have most companies underachieving their targets, the regulator could also say that maybe this year we're not going to charge a penalty to anyone, right? But maybe we are going to give some compensation by allowing the ones who overachieve to carry forward their certificates to the next year so that they have extra certificates. So there are various ways in which everything on all of these things can be done. So I have Mahesh. Mahesh also wants to clarify a few items. So I'm going to hand it over to Mahesh to actually answer, to actually get some clarity into this trading mechanism and how WRCs work.
Yeah, so Sanket has covered sort of almost all the points perfectly well. Just a couple of things related to the market part of it, the market gaming, and how frequently do we sell the change the targets. There was a very interesting question about the liquidity in the market. If the market is too liquid and there is no way that they can sell it to each other, what's going to happen in that situation? So just to give you sort of some perspective, different economies have their own regulatory mechanisms. And let me give you an example from India. India has certain water regulators, which is interested to come up with specific notifications for regulations, and these notified regulations, which mean they are required to set the stage as far as the market functioning is concerned. So alongside the blockchain hackathon, 2030 Water Resources Group is working very closely with Maharashtra Water Resources Regulatory Authority, and a few other private sector entities as a part of the 2030 WRG's multi-stakeholder platform, wherein we are thinking about what kinds of carrot and stick mechanisms one can evolve in the water sector. So most of the questions related to the markets, gaming, high liquidity, low liquidity, how the targets are set, and so on and so forth. This would get reflected in some kind of a rule book, and that rule book will go through public consultation process, which would then be notified and which will become some kind of a law. All the contributions that would be made through the hackathon itself and the blockchain hackathon itself will offer substantial confidence to any policy making authority to come up with right kind of policies so that the instances of gaming and other things are limited as to as less as possible. So just want to clarify the point related to the regulatory mechanisms and how those evolve and so on. Back to you, Sanket.
Yeah, thank you, Mahesh. So I think we actually overshot, but we still have quite a few listeners here and seem to be actively listening and asking questions. I'm going to take the last few, which I have not yet answered. So I'm going to take unique questions that would probably add value to all the attendees. So one of them is asked by Avinash, which is WRC's value should depend on volume of water reused rather than the number of companies. So Avinash, to a certain extent, what you're saying is true, wherein the WRC value should depend on volume of water reused rather than the number of companies. It is true, but what we're saying is volume equals number of WRCs. So more volume you reuse, more WRCs you earn. And then at the end of the year, the regulator would set a target at what price each WRC can be sold based on basically how many have overachieved, how many have underachieved, and what is the cost of recycling, actual cost of recycling of the water, right? So it cannot be that the penalty for the WRC is significantly more than the cost it would take to recycle and meet your target, and neither can it be that the cost of recycling is far more expensive than the gain of the WRC. So the ones who overachieve, need to make enough money to compensate for the money that they spent in actually recycling and reusing the water. So that cost is very variable, but yes, the company gets more WRC based on if they recycle more volume, they get more WRC. So effectively, they have more WRCs to trade in the market, thereby potential of making more money. I'm going to take this as the last question, which is by Wasim, and the question is, for a prototype, can I consider duration to be a week? So I assume your question is related to data. So as I mentioned earlier, we will be giving you data from about 1,000 meters, and the data will be years worth of data. So it'll be 12 months of data captured from these 1,000 meters. It's simulated data, but reasonably accurate to what you would expect to get if you actually install these meters. No names of any organizations would be provided, just the data will be provided. So you can take 1 week of data for your prototype, which is fine. And if you need to take years worth of data, that will be great. So you can actually load up that years worth of data that we give you from all the meters, compute the WRCs based on the data that's in the blockchain. I would suggest reporting the WRC count into the blockchain itself, and then allowing trading of those WRCs through the blockchain. And maybe you can also use the blockchain or say the Ethereum network to set up smart contracts so that the target that's set for the year by the regulator is actually a smart contract and not just some target set in the air. So the target should not be like a discussion done between the companies. Of course, the regulator has discussed with the company, set the target, but when they set a target, it needs to be set up as some blockchain-based smart contract so that both parties have to abide by the exact target that is set. So I hope that adds clarity to a lot of you out there. And I know we have overshot the time, so thank you all for being patient and continuing beyond the scheduled time. And I'm going to end it here. And I look forward to several contributions from your side. We will be doing one more webinar this coming Wednesday around the same time as today. And that webinar will be to demonstrate how you can actually set up a blockchain and load some of the data that we give you into a blockchain. So for those of you who are implementing a blockchain for the first time, do come in for the next webinar that's coming on Wednesday, and we will try and make you very comfortable with setting up your blockchain. And if you do need one-on-one webinar, one-on-one mentoring sessions with me, I have a few slots open. And if you're not connected on Slack, please do connect on Slack. You can ask any questions. All of us are monitoring Slack continuously. So we will take our best effort in making sure we answer all of your questions on Slack almost as soon as you ask them. So thank you very much. Thank you for this wonderful session. It's been great answering all the questions. Thank you, Mahesh, as well, for joining in today for this session and answering a few of the questions. And wish all the contestants all the best in making the submissions. Don't forget, I think we have about 13 or 14 days remaining. So start prepping up those submissions right up front so that there are no last-minute delays, and make sure you do submit on the time. And I think that's it. Have a nice day, everyone. Thank you so much.